Welcome to this lecture. In this video, I will discuss Laplace transform of the signal x of t equals to sine omega t multiplied with u of t. Now we'll see the solution for this function in two different ways. First one is we write sine omega t in exponential terms as e power j omega t minus e power minus j omega t divided by 2j. Now the signal x of t becomes x of t equals to e power j omega t minus e power minus j omega t divided by 2j multiplied with u of t. Now we apply Laplace transform on both sides. So then we'll get Laplace transform of x of t equals to. We simplify this equation and we can write 1 by 2j Laplace transform of e power j omega t multiplied with u of t minus 1 by 2j Laplace transform of e power minus j omega t multiplied with u of t. So Laplace transform of x of t is x of s equals to 1 by 2j. So Laplace transform of e power j omega t multiplied with u of t. So we write integral 0 to infinity. So here I am taking the limits 0 to infinity because of the unit step function e power j omega t into e power minus st dt. So this is the first term minus 1 by 2j Laplace transform of this e power minus j omega t multiplied with u of t integral 0 to infinity e power minus j omega t into e power minus st dt. Now the first term is having two exponentials e power j omega t multiplied with e power minus st. So in this case, magnitude of e power j omega t is equals to 1. So irrespective of the value of omega t, so its magnitude is 1. Then the expression becomes integral 0 to infinity e power minus st dt. And this function will be finite for the values of s greater than 0. So this indicates the region of convergence or region of existence of Laplace transform for the exponential signal. Similarly, the second term is having the two exponentials e power minus j omega t multiplied with e power minus st. So here also we can write the magnitude of e power minus j omega t is equal to 1 irrespective of the value of omega t. So then expression becomes integral 0 to infinity e power minus st dt. And this function will be finite if s value is greater than 0. So here s indicates the real part of the complex quantity sigma plus j omega, or simply we can write it is sigma greater than 0. So ROC of this function is s greater than 0. Similarly, the second case also is s greater than 0. So from this we get the region of convergence or region of existence of Laplace transform for this complex exponential signals. Now further simplify to get the Laplace transform of this expression. So we'll write 1 by 2j. Then first term is integral 0 to infinity e power minus of s minus j omega into t dt minus the second term is integral over 0 to infinity e power minus of s plus j omega multiplied with t dt. So 1 by 2j. So this is integral of this exponential function, it becomes e power minus of s minus j omega multiplied with t divided by minus of s minus j omega over the limits 0 to infinity. Similarly, the second term is integral of exponential 1. So it becomes e power minus of s plus j omega multiplied with t divided by minus of s plus j omega. The limits are 0 to infinity. That gives 1 by 2j. We substitute the limits. The first limit is e power minus infinity minus e power 0 divided by minus of s minus j omega minus the second term is e power minus infinity minus e power 0 divided by minus of s plus j omega. The equation becomes 1 by 2j. So e power minus infinity value is 0 minus 1 divided by minus of s minus j omega minus e power minus infinity is 0 minus 1 divided by minus of s plus j omega. 1 by 2j, the first term is becomes 1 by s minus j omega, second term 1 by s plus j omega, that is 1 by 2j. So in the denominator we take the LCM, 1 minus s minus j omega multiplied with s plus j omega. The first term is s plus j omega minus s plus j omega, that is 1 by 2j. So here plus s minus s get cancelled and plus j omega, the twice of j omega divided by s square minus j square omega square. Then the expression becomes omega by s square plus omega square. So j square value is minus 1 and minus of minus becomes plus. So this gives x of s. Therefore, for the signal sin omega t multiplied with u of t, Laplace transform is omega by s square plus omega square, and the ROC is s greater than 0. Now we'll see the second approach. So x of t signal is given as sin omega t multiplied with u of t. So that is in terms of exponential. So it becomes e power j omega t minus e power minus j omega t divided by 2j multiplied with u of t. Now apply the Laplace transform on both sides. So that is Laplace transform of x of t equals to 1 by 2j Laplace transform of e power j omega t multiplied with u of t minus 1 by 2j Laplace transform of e power minus j omega t multiplied with u of t, that is 1 by 2j Laplace transform of this complex exponential signal we already derived in the previous lecture. So that gives Laplace transform of e power j omega t multiplied with u of t. Laplace transform will be 1 by s minus j omega. Similarly, Laplace transform of e power minus j omega t multiplied with u of t is 1 by s plus j omega. Now we use these two expressions to simplify and get the Laplace transform of sin omega t multiplied with u of t signal. This is 1 by s minus j omega minus 1 by 2j. Laplace transform of the second term is 1 by s plus j omega. So 1 by 2j is there in the two terms. So we write outside and then the expression becomes 1 by s minus j omega minus 1 by s plus j omega. Now we further simplify it. 1 by 2g, we take the LCM, s minus j omega into s plus j omega. The first term becomes s plus j omega minus s plus j omega. Plus s minus s is cancelled. So 1 by 2j. The numerator j omega plus j omega, it is twice of j omega divided by s square minus j square omega square. So 2j becomes cancelled. The expression is omega by s square, j square is equal to minus 1 plus omega square. So this gives the Laplace transform. Therefore, for the signal sin omega t multiplied with u of t, Laplace transform is omega by s square plus omega square, and ROC is s greater than 0. So this is all about the function x of t equals to sin omega t multiplied with u of t and its Laplace transform with region of convergence.